So good morning all. We have already done in previous video the stability of +3 oxidation state and that of +5 oxidation state. You know that the stability of +3, that means the lower oxidation state increases as we move down the group, and that of +5 oxidation state decreases as we move down the group because of the inert pair effect. Now when we have +3 oxidation state, so at that time the compound formed by group 15 elements can be both ionic and covalent. But when +5 oxidation state is there, so that means +5 oxidation state means that this type of ion will be formed, M5 positive. But it is not possible for this element to lose all the electrons. So to lose all 5 electrons, so it is not possible to lose all 5 electrons because of the energy consideration. So now it is not possible. So instead of giving all the 5 electron, what will be there? Sharing of electron will take place. So whenever the oxidation state is M+5, at that time the compound which is formed will be covalent compound. It will not be ionic compound. Now nitrogen, when we talk about nitrogen, in case of nitrogen we have it exhibits all the oxidation state from -3 to +5. For example, in ammonia it will exhibit -3 oxidation state. In hydrazine, the nitrogen, it is having -2. In hydroxylamine it will be -1. NH2OH is hydroxylamine. In case of nitrogen, which is molecular nitrogen, so it will be 0. Okay, and in case of nitrous oxide, with oxides, so when it is nitrous oxide, the oxidation state will be +1. when it is nitric oxide, it will be +2. For nitrogen trioxide, it will be +3. For nitrogen tetroxide, N2O4, and even for NO2, if it is NO2 is there, so at that time also the oxidation state will be +4. For nitrogen pentoxide, the oxidation state will be even for nitric acid, the oxidation state will be +5. So again I am repeating, nitrogen that can exhibit -3 to +5 oxidation state, although -3, +3 and +5. Now +5 oxidation state, that will be when it is present mainly with oxygen. So at that time when heteroatom is there, it is forming bond with oxygen. At that time it exhibits the +5 oxidation state. Okay, although with chlorine like PCl5 it doesn't exist. NCl5 it doesn't exist. Okay, so it doesn't exist. So remember this thing. So ammonia -3. In case of hydrazine, again nitrogen will be having -2. In case of hydroxylamine, -1. 0 for dinitrogen, and for nitrous oxide +1. +2 for nitric oxide, N2O3 nitrogen trioxide +3, N2O4 or nitrogen dioxide at that time +4. For nitrogen pentoxide, that is N2O5 or HNO3, it will be +5 oxidation state. In the same way, phosphorus will also exhibit different oxidation state, and the oxidation state will vary for oxygen from +1 to +4. Now you know that in case of redox reaction, what we said, like when redox reaction is taking place at that time, we have reduction and oxidation taking place simultaneously. But there are some redox reaction which are known as disproportionation reaction, and here same substance, although the oxidation and reduction is taking place simultaneously, but the same substance or same element, it is oxidized. It is oxidized and reduced. It is oxidized and reduced. It is oxidized and reduced in same reaction. So in same reaction, this one substance is oxidized and reduced. For example, if we take a nitrous acid HNO2, so in acidic solution what happened, that we have HNO2, so at that time nitrogen is having +3 oxidation state, and this disproportionate into two compound, which is nitric acid and nitric oxide. Here nitrogen is having +5 and +2 oxidation state respectively. Similarly, we have phosphorus acid, and this phosphorus acid in alkaline and acidic solution, so they disproportionate to form phosphoric acid and phosphine, where in case of phosphine we have -3 oxidation state, and in case of phosphoric acid we have +5 oxidation state. So oxidation and reduction, both of these are taken